माइक्रोफोन करना होता है, मेरे को आप ही का बिल्कुल आइडिया नहीं है। Where is the microphone?
माइक्रोफोन क्या करना है?
अभी ऑफ करती हूँ ना ये
क्लिक करो।
So good evening, everybody. We have the first activity of our young tunneling group, that is on challenging tunneling in India. So we have our distinguished dignitaries on the dais. Our TAIym President, Dr. Mandu Singh, Managing Director of Delhi Metro Rail Corporation. Let us have a huge round of applause. We have Lieutenant General Suresh Sharma, Senior Vice President of Tunneling Association of India. We have Shri V.K. Kandinya, Secretary General, Tunneling Association of India. We have Dr. G.P. Patel, Director of Water Sources and Treasurer of Tunneling Association of India. And we have our renowned expert, Dr. Florin Crane, Managing Director of GeoConsult India Private Limited. Of the dais, we have our Senior Professor, Dr. Ramamurthy. So, ladies and gentlemen, I now invite our Secretary General, Shri Kanjeji, to present the welcome address.
A very good evening, ladies and gentlemen. So this is a very unique occasion when Tunneling Association of India is organizing a program for the young engineers along with a small part of technical program as well. On this important occasion, so we have with us Dr. Mangu Singh ji, President of Tunneling Association of India and Managing Director of Delhi Metro Rail Corporation. I extend him a very warm welcome. It is under his dynamic leadership that Tunneling Association of India has grown very big. A lot of achievements have been made. So whenever we are organizing any program, like we had last time organized Tunneling Asia in February 2019 at Mumbai. So we had the honor to host the President of International Tunneling Association as well as the Vice President of International Tunneling Association. So the event was very well attended and we got support from all these stakeholders. So we are highly thankful to all of them. So under Dr. Mangu Singh's leadership, so we have been able to increase our membership, our activities, our presence. So we are bidding this time for World Tunnel Congress 2022. So it's because of the leading role being played by him that we are able to reach this stage. I am sure further we will take it this Tunneling Association further up the ladder under his ever support and guidance. So sir, I extend very warm welcome to you once again. So I also welcome Lieutenant General Suresh Sharma ji, Senior Vice President of Tunneling Association of India. So though the association of Mr. Sharma has been very brief with the Tunneling Association, maybe 2-3 years only, but during this short tenure, he has contributed a lot, particularly the level of enthusiasm which has been brought about, the new thinking in the how to handle the affairs of the association, how to increase the activity, how to increase the membership, how to channelize our energies. So that has been a tremendous contribution by Lieutenant General Suresh Sharma ji. So I extend a very hearty welcome to him. So Dr. Florin Crane is the mentor, technical contributor. So he has been helping us whenever we have any program on tunneling. He is part of the program and he has always been contributing. So I welcome Dr. Florin Crane for his kind presence on this occasion. And I also welcome the dignity of the dais, the special invitees, particularly Dr. Ramamurthy, who has been a pillar of strength for us. Now you are seeing the Tunneling Association in the present shape. And the foundation for such strong association has been laid by Dr. Ramamurthy. So he has been guiding us all through as professor in IIT. Later on, also he has continued his association, and we are thankful to him for his guidance. I welcome him. I also welcome Dr. Potnis from Pune University, and so he has been a change agent in the sense that so we didn't have very strong academics presence. So now he is contributing in this field also. I am hopeful that this side, whatever deficiency is there, so it will be made up and we will be getting strong support. So I also welcome other dignitaries who are there with us today. I will welcome particularly the young engineers. So we had always been aspiring that we are all old people and going to retire, and there is nobody to take the place of the engineers who are retiring, and the number of such experts is diminishing day by day. So we were always thinking how to have the young members, enthuse them, increase their number, participation, activities, etc., etc. Because at the international level, a lot of stress is being laid on the participation of the young engineers, women engineers in the activities of Tunneling Association, International Tunneling Association. So I am thankful to the young tunnelers that they have come, not only come, but come in a large number, and they have associated. So with minimum support from the Tunneling Association or our senior members, so they have been able to constitute themselves into a group, and a very cohesive and vibrant group. I am sure that this group is going to contribute and be there for a long time. So I urge them to associate as many as more members, student members, young members, so that this group becomes still more vibrant and we can play a still bigger role at the national as well as international level. So my colleagues, Mr. Dr. G.P. Patel and Mr. Sunil Sharma, so they have been working very hard for the various activities of the Tunneling Association. So I welcome them. So we have another stalwart with us, Mr. Daljit Singh, Director Delhi Metro Rail Corporation. So being the right-hand man of our President, Dr. Manmohan Singh, so whenever we have any problem, we first approach Mr. Daljit Singh, and most of the issues are being settled at his level. So today we had just before coming here, we had a meeting of the membership committee. So how to increase the membership. So I'm glad to inform you that DMRC has enrolled 32 members recently, in addition to being the institutional member. So I will request and urge other members also, the institutional members, other professionals, to kindly come forward and increase the number. So if we have more members, both at the institutional level as well as individual level, so it will go a long way in increasing the activity of the Tunneling Association. And the tunneling is being carried out in many sectors. The pace of construction, previously which was there only in the hydro sector, now it has expanded to the metro, the railways, the highways, the water supply, sewerage, etc., and underground storage space. So a lot of activities are now taking place. It's high time that we assume a leading role at the international level and play a due role, which we need to play. Being this is such a vibrant economy in India that all sectors, this tunneling is playing an important role in all these sectors. So with these words, I again extend a very warm welcome to all of you. Thank you. Thank you very much.
So thank you very much, sir. To welcome our dignitaries on the dais, I request Shri V.K. Kanjalia to welcome our dignitary by presenting a bouquet to our president. Bouquet to our senior vice president, Shri Suresh Sharma. and bouquet to Dr. Florin Kim. So thank you very much, sir. May I now invite our Senior Vice President to say a few words.
President of the Tunneling Association of India, Dr. Manu Singh. Friends and colleagues on the dais, and our special, I would say, not the guests, but the co-host of the event in the evening today, that is the young tunnelers of India. It's a very special occasion today. This happens to be the first one that we are together to organize an event. And congratulations for that. 2 or 3 things I would like to highlight. One is that we often deliberate as to what is the role of the Tunneling Association of India. What is the mission that we should set up for ourselves? How do we need to further validate our presence in this industry, both at the domestic scene and at the international scene? There's a lot of ground to be covered. Tunneling, I always say, is a very myopic view. Tunnel is nothing but a passage from place A to place B underground. The broader view of that in the modern world today is the underground space. That's how slowly you are finding that in the nomenclature, Professor may not agree with me because this is a new terminology being thrown up today, that more and more of this space is being used today, and more of this word is being used today to describe what we do, which we earlier used to describe as tunneling, is being used, the nomenclature is being used as today, the underground space. And if you now start seeing, following the international arena, you will find this usage more and more. So much so that this year the theme of the World Tunneling Conference, which is going to be done next week and onwards in Italy in Naples, has been the archaeology, the architecture, and the art in the underground space. This is the theme of that. Just see the way the world is now moving today, from making just the tunnels today. The whole cities are likely to be thrown up at some stage or the other. As survival or the resilience of those so-called underground cities is already a thought process in the mind of young planners and the young tunnel engineers. And that's why I'm just leaving a food for thought. And this theme, incidentally, was caught up. The idea was caught up by the Italians very smartly 2 years back. This word was used by some of us during one of our deliberations. Okay, that much. Now, the future of underground space in India is huge. When we talk of the tunnels per se, whether it is the highways, or it is the metros, or it is the rail, or it is the storage, special storage, and also the what you call hydro tunnels, I think there is a total proliferation. And the future in the infrastructure projects is more and more on the underground space. And it is no longer the highway tunnels only. We have already done one underwater tunnel in Hooghly, and there is thinking on this, not only under the rivers, even under the sea beds also. So these are the future technology, these are the future challenges. All of you have a lot of scope to work in India and abroad. I'm sure some of you have already had an experience of working outside. Please gain as much of experience and as much of expertise that you can. Go abroad, study abroad, come back, work here, work there. But the knowledge that you gain, the confidence that you gain, experience that you gain must be gainfully utilized to further authenticate and validate our own. Very recently, we had gone to China to attend one such conference in one of the cities in China last year in November. But what came out very loud and clear to the international community by the Chinese was that today we have our own designers, we have our own researchers, we have our own engineers, we have our own equipment, we have our own materials, we have our own protocols. We hardly need people coming from outside to help us. And we are doing fantastic tunnels. In India, repeatedly we keep saying I'm from the border road, so we kept saying that the highest tunnel in the world, 13,000, what we have today in Jojila. Not Jojila, the Rohtak. But what turned out is the Chinese have done a tunnel at 14,517 feet. And they've already finished it, 14 kilometers long. Highway tunnel. They're fast. Okay. So a day is not very far. Our young tunnels should have also got this kind of experience, this kind of knowledge base, that you must, whatever you have, consolidate that we should have our own engineers, our own designers, our own protocol writers, okay, and all the associated activity. And the world should look at India not only as a favorite destination for the work, it should also look at India for a favorite destination for picking up the best designers, for picking up the best tunnel engineers, and for picking up the best professors if they were to teach the field of tunnel engineers. So that's why we are addressing this group. That is what you would do. Okay, there's a huge gap and a huge disconnect. The young and not so young people like us, who are, who need to be almost getting things out. And this is, I will not take more time. And I'm already looking at very brilliant young people. Okay, and each one better than the other. And you have a lot of future. And this is a very, very fascinating industry. Mr. Kanjalia mentioned to me, I got associated with channeling last 3 years of my service. Seriously. And I got so much taken out of this subject that I'm reading about it. I'm visiting, I'm seeing, I'm discussing. And this is it's really, really very, very fascinating. This is what they say, that one of the best civil engineering fields is the field of tunnel. Because the amount of challenges that this throws to you is nowhere closer to what the others can. Everything else is apparent. Here is the field where there are surprises, technical challenges and surprises, and engineers have to be on top of it to manage those challenges. That's what and you can participate in different fields. It is not that okay, you have to get to Kung Fu only A piece. No, these graduate on to become good project managers, good project engineers, good project designers, good project leaders. Eventually, you will manage the team, you will manage the company. And that's how the world moves. That is how you should move. And with that, I wish all of you great innings and consolidate further, be a very, very strong proponent. And I'll also utilize this forum through you to spread it through your friends, seniors and juniors in your companies and other way, wherever you go. Please come and join this organization. Let's have one cohesive professional body to address all our needs. With that, thank you very much.
Thank you very much, sir, for your motivation to the young tunnelers. I may now invite our president, Dr. Mandu Singh, to address the young tunnelers.
General Sharma, Mr. Kanjalia, Mr. Kren, Mr. Patel, other dignitaries of the dais, Mr. Ramurthy, the young colleagues, and friends from the tunneling fraternity. Today, actually, I'm feeling great while launching this TAIym Young Members group formally. This has come into existence already a few months back. And I must congratulate and compliment the team, Mr. Kanjalia, Mr. Patel, Mr. Sharma, in organizing this Young Members group. Almost all such institutions, they have a young member group to give them a sort of a freedom to think something new and contribute to the institution. So I think it's a great thing which has happened to Tunneling Association of India, and I congratulate all the young members. I also congratulate the
team for organizing this today's conference on challenges in tunneling. You certainly have three very well selected topics and very well speakers today on important topics which really deals with the challenges. What fascinates me tunneling actually is that you can't deal with tunneling in a bookish manner. There is no standard rules and sort of theory. Each and every case will throw a challenge to you. If you want to go one step further, it is not only the challenges, it is you create the challenges. You actually dare, say, for example, tunneling in urban area. You have an option to have an alignment which is away from the buildings, much deeper, so that it doesn't affect the settlement at the surface will not be significant and it will not affect any building at the surface. You can choose that. But that will not serve the purpose for which you are building it. It's a sort of a creation of challenges. You need to be as shallow as possible for the purpose of the ease of using the facility. Otherwise, you have to go deep every time when you use the facility. And from the point of view of tunneling construction, it is better the deeper you are, so that you can easily do the tunneling. So I compare the tunneling with the kabaddi match. You are a raider actually. You have an option just to go and just touch that line, mandatory line, and come back. Or if you want to score, you have to dare, go inside, and then take the point. So the same way the tunneling, particularly in urban area of which I am in more, there are many challenges, all of you know. But the point I mentioned of taking more challenges, daring, is very important. I like to give one or two examples in the metro history. Apart from the typical normal challenges of settlement at the surface level in urban area, another challenge which is very common in urban area, that you can't do the 100% geotechnical investigation because of the surface is not available even for doing the boreholes. So this is one of the major challenges. Another important challenge is when you go through an important working facility, like a metro line is already working, and you want to do the tunneling below that or above that, adjacent or very near to that. So it's a much bigger challenge, much more challenge. The challenge you have chosen that challenge. INA station on line 2 of our operational line 2, the Gurgaon line. And in phase 3, we had to do the tunneling for line 7, that is pink line, crossing this. Now, the obvious proposal was to go much below the existing running tunnel, leave adequate gap between the two, and then go down. What it would have resulted in? Construction of a station which was very near, much deeper. At rail level would have been at say 28 meter deep. The cost of the station would have been astronomically very high. Therefore, even here is the question of taking challenge. We decided that we will not cross below, we will cross from the top. And when we were crossing from top, hardly above the existing tunnel, hardly about 9 to 10 meter gap was there. In that, you have to create a 6 meter box for housing this new line. So you hardly have any gap between the running tunnel and the bottom of the new tunnel, and also hardly any cover on top of it. But that was the challenge. That we took that challenge. developed the methodology, how it can be done. And finally, we completed that tunnel. And as a result, we saved at least 80 to 90 crore. So these are the type of things, challenges, which you create the challenges every day in the learning. I'm very happy that some of the very important topics have been selected for today's deliberation. I will not take much time. I once again hope that this today's lectures will be very useful for young members will certainly get benefited. I also wish that this newly created group will be very active and will certainly contribute to Tunneling Association of India and take TAI to further bigger heights. And I once again congratulate and compliment to the entire team. Thank you very much.
Thank you very much for your about the TI, this young terminal group. There is a small presentation. So I invite Mr. Sandeep Singh Niruna, who is basically the chair of this young terminal group ad hoc committee, to update the members about this group, TI young member group.
Good evening, everyone. First of all, I would like to thank Tunneling Association of India to help young engineers to come forward and give us a platform to share our work, to make some mistakes on this stage, and to learn as we go. I would like to especially thank Mr. Sudhir from TAI, who has always helped us and always motivated us to grow in numbers and to organize this first event. In my presentation, I will talk about Tunneling Association of India Young Members Group, its purpose, its journey so far, the organization structure that this group will have, annual activities that we are planning, and what is expected in future from this young tunneling group. TAIym is child group of TAI. It's a platform for young professionals, be it engineers, consultants, clients, architects, manufacturers, vendors, or anybody who is associated with the tunneling field, up to the age of 35 years, working in the industry. But it works in a close coordination with the International Tunneling Association and Young Members Group of International Tunneling Association. Young members are already making international presence, which as far as I know of, there are 3 papers from India which are being presented in World Tunnel Conference 2019 and Italy this year. 2 are from Delhi Metro Rail Corporation, one from Mr. Ujjwal, who is here among us. Another one, I'm not sure about the name though, the third one from myself. And we are looking forward to increase this number as we grow further. The purpose of Young Member Group is to explore and motivate young tunneling professionals, give opportunities to interchange and share ideas and motivate each other, a space for experienced members of TAI to directly interact with young members and mentor them about the best practices of tunneling industry, collaboration with national as well as global industries and academic organizations, develop management and leadership skills by and TAIym with assistance of TAI, promotion to write papers in national as well as international conferences and journals, promote and recognizing innovations done by young years and posting them online, we have a pan-India approach. Since we are a very big country, once a conference happens at one place, the people from the vast majority of India are unable to attend personally. So what we have started from today itself is webcasting of all the events that TAIym will do live on YouTube. Right now it is being webcasted, and the laptop that we see is streaming it live on YouTube. So we want to involve everybody across India. The journey so far. The idea began in 2017. Everybody AI committee. We are glad that everybody appreciated the idea, and the group. And further, we started to increase the unofficial approach to involve as many young engineers into the group as possible. 18 unofficial members were included by the end of May 2018. Then by the end of August 2018, we grew to 25 unofficial members. We discussed with IIT Delhi so that they collaborate with the young members group so that we can interact with students occasionally and share the tunneling practices with students and motivate them to come to tunneling industry. An article about young members was published in the journal 2018. We prepared mission, vision, and objective statements and created the organization structure. This was a contribution of a lot of people, as we can see on the screen. People from various companies came together to come up with this organization. We were unofficial by then. By November 2018, we got stronger. We had 50 unofficial members. We got assistance from Mr. Senthil Nath, who is working in Singapore with GeoConsult, and he guided us as he has already been working with International Tunneling Association to set up this group. We prepared and planned the annual activities of TAIym, and we started preparations for launching of TAIym. The team, which motivated professionals from various companies, came together to do all the effort. Then officially, the group was launched in December 2018 in Delhi, in Metro Bhavan by Dr. Mangu Singh, President of TAI and MPD-MRC. And the discussions for framing the constitution of TAIym is ongoing with TIA and TAIym as of at the moment. Once we were officially launched, we got 40 official members by February 2019, and we did a small event at Tunnel Asia Conference by displaying a stall about young members in Mumbai. And we got a lot of members from Mumbai involved with the group as of now. And probably they'll be watching this stream live, as I already shared. Then we started collaborating with International Tunneling Association. And we made LinkedIn and Facebook groups to make our presence felt globally. We are being appreciated by comments by the president of ITAIym, International Tunneling Association, and the noises are being heard. At the moment, we have more than 50 members officially. An article about the young members is going to be published in International Tunneling Association newsletter, and is going to be published in the next edition of Breakthrough magazine, which is launched by International Tunneling Association young members. And welcome to the event at CBIP. We are happy to see so many faces. The organization has a chair, being myself, vice chair, who is Akshay Mitra from GeoConsult, secretary of professional development, who will be looking after the events and the content of the event, secretary of media, who will be looking after the social media posts and webcasts, secretary of coordination, who will be associating the group with academic as well as professional bodies, secretary of resource management, who will be looking after the finances and will be managing the coordination with you. We are planning 6 activities as of now, with frequency of 2 activities, one activity every 2 months. 2 regular events like this, the one we have today. 1 social event, we can book a venue and we can do just a social event to know each other, to interact with each other. One annual conference, a 1 day long whole conference where every young member will be given a chance to share their work. And one exchange event with Singapore. This is very interesting because Singapore is about to launch their young members group, and they have reached to us to do an exchange event with India's young members group annually, where few professionals from Singapore will travel to India, and alternatively we will travel there to share our ideas and make better business linkages. One site visit or one visit to school or university annually. For this, we are trying to tie up with L&T because they have started with a TAIym academy and they will be manufacturing TAIym soon. So we are looking forward to do one site visit to TAIym academy this year. What is expected of the young members group in future? We want to create a database of experiences of tunneling professionals using a blog of TAI where anybody can post their experiences and we'll publish it. And a YouTube channel, we will record all the events, all the presentations and put them online so that anybody, whenever need and help of a similar nature which was presented by a presenter, can reach out and get an help. Representation of Indian young professionals in International Tunneling Association Young Members Committee. We want motivated young engineers from us to go and represent us on a global platform, take responsibilities and get involved. Preparing to organize Think Deep initiative in India 2020. We may not be knowing about this initiative, but it is unique in its nature. People from around the world, around 20 professionals, come together for a week and they debate on one specific issue and they come out with a solution for that. This has been done for Glasgow, and as of now we have proposed two problems from India. One is to manage Chandni Chowk traffic and one is to improve the waterfront of Yamuna River. So probably we are looking forward to take it, to grow it and to bring Think Deep initiative to India in 2020. Encouraging young professionals to write and publish papers as I already discussed. Thank you very much. Happy tunneling. And do join us on
One suggestion. Instead of telling, this is TAIym. You teach a TAIym. TAIym means education. It has some meaning in that. So don't say Tunneling Association of India Young Members. You can call it TAIym.
Thank you.
So, thank you, Mr. Sandeep, for giving a brief background about the young tunneler group. Our next speaker is Dr. Florin Craig. Sir, our president has some engagement, so he would like to go. I request everybody to use round of applause to the president. So we look forward to your support and presence in the next event also of the young program. So now I request our Senior Vice President to chair this session, and our speaker is Dr. Florin.
Thanks a lot for the introduction. I hope you can hear me properly now that I'm wired. And really congratulations to the young members of the Tunneling Association. In our office, I was quite proud to see that half of the committees are made by our people. like a monopoly. But in the office it was very quiet. It was 2 or 3 times that can you do this, can we do that, can we put it on sponsorship. But seeing that, I'm really happy. This topic is one of the topics you have not heard from my end so far, but it is something that is a little bit on my heart, and I think we can put it forward, especially for the young people, because somehow we are now having a bouquet of design tools nowadays, which is really great. But I think sometimes we need to take a step back and ask what direction are we going to. So just a brief overview. What do we have as analytical design tools? And it's just examples, very simple tools which help us. Then 2 slides on the failure modes for rock mass. Then I'll present a little bit on numerical tools, and then some conclusions and food for thought. Because with all the tools we have, we need to look into their use and into the proper use. So many of you may know these analytical and even graphical tools. You know, I mean, there is this Kuhlmann procedure to assess the earth pressure. Usually people have done it once in their lifetime at the university. And then done. You can even make a vector diagram to assess block sliding. Then there is these procedures for assessing slope stability, according to Fröhlich, then Bischoff. All these things, we have the solution for a circular hole in the plate. We have very quick rock mechanics solutions with stereographic projections. And then, if we go deeper into the tunneling or into underground openings, we can also go manually surf on the stress functions, and it's all then differential equations, so a lot of maths. Now, one example. Very simple, a sliding block, and we want is the anchor. So we need to know the weight that we know. We need the angle of the sliding plane that we know. Angle of friction, that is an input parameter with some probability associated. We say that we have no cohesion. We have an angle which the anchor forms with horizontal. So that drawing takes 5 minutes. And if I'm using it on a free paper, I have an accuracy of 5%. The accuracy of 5% I don't have for the angle of friction. So this already helps us, you know, to get one step in for the first assessment. Then for our tunnel lines. The first check of a lining load can be always done with this Wessel formula. Whether you take the full overburden, whether you take some other loading, some support pressure you may want to generate to keep the rock mass in place. This takes a few minutes. And then you have some idea what load will be my lining. Shall I make it thicker? Will it work out? And all these things. And then it becomes sophisticated, because that already gives me an analytical solution for a circular tunnel. But this solution, if you can see here, is even considering a plastic zone around my tunnel. So this is now a bit more work. If I do it manually with a pocket calculator, it will take me a lot of time. If I put it into some software, like MATLAB, it may take me lesser time, and I can even do some probability studies, what will happen when. Oh, that got a bit shifted. That should not be there. Sorry. Because it should. Seems to be the one. So, no presentation is risk-free. Ah, that looks better. this was the very simple design tools we can use for the first check. And then, since we are in tunneling, we are dealing with rock mass. So what failure modes do we have in rock mass? We have spalling, we have a shear failure. In layered rock mass, and in Himalayas we have it many, many times that the rock mass is layered. We have structural failure, which is not very common until we come into high overburden, and key block failure, which I will not go further. It basically means that our joints are in an orientation that the block may fall out of our tunnel ground. Now, one thing, the depth of the failure will always define my failure mode, because close to my tunnel surface, I have no confinement pressure, so I will have spalling. Then if I go deeper, I may have a shear failure, because I have some radial stress here. And if it goes even further, then there would be a structural failure. And now, the possible beauty of that whole thing is if I'm sketching up a layered rock mass, and this time here the sketch is for a vertically layered rock mass, I can treat it even like a small column. And if I go further, if I have rock bolts, I'm cutting down this length. So the ratio between the length of the element and the thickness changes. Here is a diagram. Basically, 1 would be the cube strength, 2 would be the strength, what we usually have in a cylinder, and so on. And with the slenderness, we have a decrease in the strength of this area. So when we do the stress analysis, a simple one with a hand calculation, we can already say, okay, in this range, approximately, we will have our utilization of the rock mass. But it requires that we treat it like this. Again, one thing that is now not even an analytic thing, it's really just a thinking or a model, is how will a shear failure in a deep tunnel develop. First of all, we have the tunnel in the initial stress state. Then there will be some failure very close to the surface where these jaws would come in, all without any support, naturally. Then once this is there, this whole thing changes again, and the stresses in the ground and in the invert would eventually lead to some upheaving and to some failure in the ground. And I tell you, this is just a diagram. There are sites where you can really see that, with convergences up to 50 centimeters. And it is very difficult when you make such a sketch to convince the contractor that the rock bolt would be a good idea. And then the really sophisticated analytical solutions would then be if I have a tunnel and this shear failure occurs, because I will have the first shear failure. If I don't do any measures, then I may get the second shear failure and a huge jaw coming in. Now, what have all these hand solutions in common? First of all, they require some mathematical skills and efforts. They require accuracy in sketching, time and effort for the solving of equations and also interpreting the results, because you have to go back and forth. And that is common to them, they require a model, as they are all abstractions. It's not something you say, it's now coming automatically. We have to first model the failure mode, then check it, then go back again. And they give approximately right answers, because many of them are also based on assumptions like that we have an isotropic half space, especially when you take the normal formulas diagrams for settlement, which can be used and give a good result, but they are based on an elastic half space. And I think that's the biggest shortcoming for many people. We make one check at a time, but it's not a comprehensive analysis. We take a new page and then we check the next thing, we check the next thing. All in all, we will come to the comprehensive analysis if there are no big contradictions, but it's not that we have everything in one go. Now, what is our latest thing? Since the 70s, we have the numerical modeling. So this is the big thing. It's used everywhere. When you are in a metro project, the first thing is the question from the general consultant, do you have a numerical model? And usually you have to do one then. Now, what do we have now? And this is I think not an exhaustive list, but we have finite elements, very well developed, finite differences, everybody might have used flag already. We have boundary elements, which are more common in mining than in tunneling. We have distinct elements, and now we can model the ground and all our support measures in one go. So we get very colorful pictures. I took some examples. We can model tunnels in layered ground. We can model a tunnel with an upheave due to groundwater coming up. Now this is something very interesting if you look at this, because it shows a D-shaped tunnel and a very really sophisticated numerical simulation with distinct elements. But what is the interpretation of that? Who would come to the interpretation that this cross-section is maybe not really the best cross-section for a tunnel? Or everybody will say, oh, I'm having 5.5 millimeters of displacement. And this is something which is coming a bit more in the range of approximately right, because that's boundary elements, which is elastic, but I know where my stresses will be. And I know it in 3 dimensions. So I can introduce certain features. Now, as already mentioned by our Vice President, food for thought, even built in here. And that is the first thing. All these very great packages deliver results with many, many decimals. So it looks as if we have an exact solution. And they are very convenient to use. And we can even model very complicated interactions with interface elements. We have support elements. We can take it out. We can put in the inner lining. All these things can be modeled. But then we have to ask ourselves always, do we really have all the input parameters required for a proper simulation? Do we have that? Do we have a proper geotechnical investigation? Maybe also some modeling of the ground, because that's the second thing. Do we model the ground properly? With the numerical packages, you have, 10, 20 material models, but getting the input parameters, you would need a lab for you to get all these parameters. And if you use some parameters, you are again approximately right, maybe approximately wrong. You cannot say. But this is, I think, the biggest thing. And, well, one thing for the young generation to insist on that. Proper input parameters. And then one big caveat. Most of all these packages are continuum models still. And rockmass is a discontinuum. So we are having crotches already, but we say our crotches are turbo. They are not normal crotches, they are much better, and they give me 10 decimals. But still, it is crotches. So, and one point which is really, I think, important is when we go into the numerical modeling, there is always the threshold of detailing. When we go, for example, in shallow tunneling for a pipe-proof umbrella, I know one guy who did it for his PhD. It took him 10 years to finish the PhD, but he modeled the pipe-proof at the end that it worked. The problem is really, shall we go for such solutions, or shall we say, okay, we are happy with an approximate solution, because the rest in tunneling, with all our uncertainties, we have to solve with observation. And that gives me some ideas which I want to convey. Have a hand sketch first, showing also the geological structures when you in rock. that gives you some idea what can happen, what can fail. Where is the weak part? Have a shorthand calculation also. And never ever forget, if you have a 2D model, a plane strain model, it is of infinite length. It is as if you take a tunnel of 1,000 kilometers and you do the top heading. It won't go. Check your parameter sets, always. And then one thing, angle of friction 19.241 degree. You read it sometimes in reports, but that is kidding. I'm talking about a natural material where I have a spread of a few degrees. But I give this because it comes, for example, from rock lump. I'm having some intact rock strength, I'm having some other parameters. I'm basically doing a patchwork to get some rock mass parameters, and at the end I'm coming with that. It's somehow a disconnect. So we have to check always our parameter accuracy versus the natural deviation. And the big question is if we can give 2 decimals, even 1 decimal, and we have in the codes the factor of safety for the material of friction, for example, angle of friction up to 1.5. If someone knows statistics, we have a mean value, we have a standard deviation. If you take standard deviation times 1.5, you cover already quite a good percentage. But it would mean that the mean value and the standard deviation are the same value. So this is really something to cover up a lot of uncertainties. So we should avoid this. And one big caveat coming also from the models for the rock mass failure is that please never use index values to derive the input parameters for finite element calculations. So you are doing something with one value, put it in, you get from this one value the approximation for 3-4 parameters, and then you calculate and say this is it. It's very dangerous when it comes to a detailed design. And I give only one example because that was a good experience. It was a layered rock mass, what was there, and so to say the advisory report at that time said we want to have ULEC. That's a distinct element program. Some of you might have used it, really powerful thing, but that was preferred for the design. During the excavation, the dominant behavior was not the layered rock mass. The dominant behavior was a time-dependent behavior, so we were exactly wrong. And then, during the course of the project, apart from other programs which were used at that time, there was a switch to a finite difference code with a proper time-dependent model. At that time, FLAG could do that very nicely. And then the whole redesign was run with that. The observation results, and then the project was concluded successfully. The failure project I'm not projecting, but in Brazil, in Sao Paulo, in the metro, there was a huge collapse with casualties, and it was then traced back in one of the experts. So it was smeared, it was like a thing that is working in all directions the same way, but it was not. And unfortunately, one of the weak planes just happened to be so unfortunately located that it collapsed. So and now, the last thing, at the end of the day, we are engineers and not data entry operators. So, thanks a lot for your attention.
So thank you, Dr. Florin. We now invite our next speaker, Mr. Ajaz, but I request that since we are overshooting the time, you have to limit your presentation to 12 minutes. 12 minutes.
Sorry.
Good evening, everyone. My voice is clear. So,
My
You also complaints? Complaints?
I'm from Mumbai.
so my topic is challenges in geotechnical during the design stage of tunneling. So, my main emphasis is on USDRL project, that is Udhampur Srinagar Baramulla railing project. So, what type of problems we face during the execution of geotechnical investigation and geological investigation? Before starting my presentation, I just want to quote Palmstrom and Cook. They have written very good paper. If you get time, then you can start this thing. You can read these papers. First of all, the average tunneling progress of 40 to 80 meters per week. This is the data from the European Tunneling Association, not from India. A key to a high capacity and low cost has been the continuous exchange of experience and the close cooperation between the engineering geologists, the designers, and the contractors. Normally in India, what we are doing, engineers are normally doing the support system and all these things. But my suggestion to all the fraternity is, before doing any support system, it's better to contact. Always get the geologist at site. First, geologist will observe the rock class. If he is suggesting something, like if he is saying that at this particular area this bed is forming, and kindly provide this additional support system, kindly listen to him, because he is masters in geology. If he is suggesting something, then it means there is some point. Third point, the cost of geotechnical investigation is between 0.25 to 4% to the construction cost. Like if we are constructing a tunnel of 100 crore rupees. So in Europe, what they are doing the geotechnical investigation at a very large scale. They are spending a lot of money in geotechnical investigation. That's why they are not encountering the major geological surprises. But in India, it is very less. The last point is design should be utilize the rock itself as the principal structural material, creating as little disturbance as possible. Because if we think that, somewhere like in Rohtang, some were discussing about Rohtang, the maximum ore burden there is almost 2000 meters. So you cannot think that your 4-meter rock boards or 6-meter rock board is sufficient to hold this thing. You are providing only initial supports. Okay, so it's better to design your tunnel, design all these stuff in such a manner that your rock itself is a supportive. Now, what are the challenges we faced during the USDRL project? Number one, insurgency. As all of you know about the insurgency period in Jammu and Kashmir, extreme snowfall, high rainfall, flood. We have already seen the flood in Kashmir. Landslide. If landslide is present, no vehicle can move in that particular area. So your materials like short pitch equipments, cement, etc. You cannot move your vehicles. Varying geology. Why varying geology is very important? Because this USDRL project, whole project is in the Himalayan terrain. So here the geology, you cannot predict the geology exactly. Like if you are doing the tunneling in southern part of India, you will get the rock type of the same type. From kilometers you will get the same type of rock, but for the Himalayan terrain, it's not possible. Like high overburden, we have encountered higher overburden in this particular area also, thrust zone, then highway problem. So now I'm going to start the design component. What are the design components? Number one, planning the location. First, we will plan the location. Then dimension and shape. What will be my tunnel's dimension and shape? Then orientation and layout. What is the excavation procedure? Excavation procedure means what type of tunneling technology we are going to adopt, either it is TAIym, CBIP, or any other. Then excavation procedure. Then support selection. What type of support selection we are adopting. Then finally instrumentation. This is very important. Instrumentation in TAIym is very important. Like in instrumentation, normally we are using 3D monitoring boards, multi-point board, extensometers, strain gauge meter, pressure cell, etc. Now the sequencing of geological exploration. Actually, I'm not detailing about all these things because time is very less. So I'm just reading. Investigation reconnaissance survey. At a glance, we are doing the reconnaissance survey and collecting what the information we are getting during the reconnaissance survey. Then after we are doing the detailed geotechnical investigation. After that, we are doing this. After this geotechnical investigation, when we are exploring, when we are excavating the tunnel, this investigation procedure continued during the execution phase also. Then during the reconnaissance survey, what are the things we are noticing? Number one, survey of morphology, survey of petrography, stratigraphy of the particular area, hydrological condition of the area, study of the previous data if previous data is available, then aerial photograph, then geobotanical integration. Then detailed geotechnical investigation, what we are looking, number one, physical strength of the rock, chemical properties of the rock, what are the fissures, then relative density of the rock, consistency, what is the consistency of the rock, what a particular rock type of the area, what a particular rock type extend how much meters or how much kilometers, then dip and strike of the rock bed, then study of the faults, then number of the joint sets present along the alignment, what are the number of joint sets, location, quantity and chemical composition of the groundwater. Then geological investigation during construction phase. The investigation should be continued during the construction, not only in the interest of checking the design data, but also ascertaining whether the deriving method adopted is corrected or needs to be modified. Initially, when we are designing, we are telling that, okay, this particular method you have to adopt. But during the construction, if we feel that, okay, no, initially we decided wrong, now we can modify. That is why probe hole should be driven in advance and to take samples studied properly. What is probe hole? Before the excavation, we are doing some probe holes. Why probe hole is required? To get to know what sort of information we are getting. In core drilling, we are taking a constructed, we are getting a core. But in probe hole, we are getting some chips. While through the boomer, when we are drilling this probe hole, we are getting some chips, and we are analyzing that chips and return water color, what is the rate of penetration, etc. And after that, we are taking a decision. Okay, this particular rock type may be encountered in future. With the help of all these data, we draw a geological profile along the boreholes location. Like this, you can see. This is the geological L section. What type of rock type we will encounter during our execution phase. All these data we are getting after the geotechnical investigation. Exploration should be extended. Number one, investigation of the top cover, orientation of the beds and quality of subsurface rock, drainage condition, position, type and volume of water contained by the subsurface rock. Geological exploration comprising original and actual condition of the rock, the collection of what are all these things? We are collecting all these information. What you see previously, this before making this L section, we are making all these reports, we are collecting all these data. Origin and actual condition of the rock, the collection of the hydrological data, the data of underground gases and temperature, the determination of physical mechanical strength of the rock, and geological features. Detailed investigation, geological consideration, detailed investigation studies, careful exploration of the geological condition, geological and hydrological condition. Mechanized methods have greater rates of progress, but it requires more specific data. A local geologist, if we are getting some local geologist, we are working in USBRL project, and if we are getting some local geologists, then it is very necessary to consult those local geologists. The general path of the tunnel is governed by existing traffic of transport interest, while the exact location is controlled by the geological condition prevailing in the area. An important consideration in selecting the location of the tunnel portal. These are the design components: aerial photograph, drilling, geophysical method, surface study. I'll just pick it up one, that is drilling. It's a method to collect the subsurface data in the form of core samples. Observational items during this drilling are core recovery, RQD, and test results of the samples. Engineers and geologists engaged in interpretation of the rock mass quality and drill holes need to realize the extreme importance of good quality drilling and realistic interpretation of the rock mass in situ. Why this realistic interpretation of rock mass is important? Because we have seen in our project area there are certain places the geotechnical investigation is going on. Sometimes they are saying, okay, अरे यार पहले वो बोरहोल लॉग नीचे लेते हो, मैं नीचे बैठ करके लॉगिंग कर दूंगा. So this type of logging they did. So on that time, when this core sample were they were carrying this core samples through donkey or somewhere, some of these animals. तो कभी कभी क्या होता है, जब लेकर के नीचे आ रहे होते हैं पूरा बक्सा पलट जाता है. अब इधर का कोर उधर हो गया, लेबर को तो पता नहीं है कि कौन सा कोर कहाँ पे था, उसने जैसा लगाया नीचे आने के बाद जियोलॉजिस्ट उसको एनालाइज करता है, उसी हिसाब से लगा हुआ है. So it is very important. In addition to good quality and well-maintaining drilling equipments operated by skilled and experienced personnel, log of the drill holes should be done by the geologist, where the drilling is actually being done or immediately thereafter, so that the experience and feel of the operator during different stages of drilling is also considered as input to logging of the boreholes. The same what I told you earlier. Quite often it is not possible to drill holes along the alignment or depth constant, for which test drilling is in most representative adjoining type sections may be considered. What is happening? You cannot drill hole along the whole alignment. At some places you are getting overburden 800 meters. अभी क्या 800 meters का borehole करना पड़ेगा? That's not possible. So orientation of the bed, like what is your dip amount, what is your joint amount. So you are extrapolating all these data through this thing. Then data output and input from drill holes form the basis of prediction of the disposition quality of rock mass likely to be encountered in underground. Accuracy of such prediction directly dependent on the okay. Core recovery. Core recovery कैसे निकालते हैं? The simple thing is length of the core divided by length of the run multiplied by 100. This is the formula of core recovery. Classification of recovery is, if you are getting your core recovery 90 to 100% means it is very good. If it is less than 25%, it is very poor. Rock, same as rock quality designation. Measure the degree of fractureness, joints and discontinuities of rock mass. The formula is sum of the pieces whose length is greater than 10 cm divided by total core run. Like if your RQD is less than 25, then it is very poor. And if your RQD is between 90 to 100, then your RQD is excellent. This is the process for measurement of the calculation of RQD. Like this is my core. Okay. So, sorry. So, so length where we are getting more than 10 centimeter of pieces is 38 centimeters, 17 centimeter, 20 centimeter, and the total is 35. So we will add 38 plus 17 plus 20 plus 35 divided by total length of core run is 200 multiplied by 100, that is 55% of your core recovery. These are the sampling methods which I discussed earlier. अभी ये ऊपर से नीचे आने के बाद अगर ये सैंपल उठ करके यहाँ आ जाएगा तो पूरा डाटा चेंज हो जाएगा. इसी वजह से कभी भी लॉगिंग जो भी होगी वो एट द पर्टिकुलर साइट ही होगी. These are the rock samples we encountered in USDRL project. After this, we are making this type of particular bore log. What is the lithology, different type of RQD, fracture frequency, size of the hole, casing, etc. Influence of geological features in tunnel. What are the rock types, stratigraphy of the area, fold, fault, joint, weathering, and cast topography. These all affect on your tunneling procedure. Geological investigation's main purpose is to preparation of the DPR. During the DPR stage, we are doing this geological exploration, investigation. After this DPR, we are doing some detailed investigation also. Geological data information is collected through old literature, satellite imagery, aerial photograph of the regional setup. Site geological data is collected through geological mapping, subsurface exploration through drilling and geophysical surveys. Besides the geological setting along the area, remote projection that are best available. Lack of proper access, like paths during surveys and investigation. What are the problems we faced in USDRL? Like there is no path. So how we have to go in that particular area? Definitely you have to walk for this surface mapping and exploration purpose. It is prudent to spend unreserved efforts and money in developing additional paths and access, particularly covering major rock exposures and reaches geological significance. The last, it is difficult and time-consuming task, but the extreme importance of such mapping for proper layout, design, and construction of underground works like tunnels make it imperative that is work is done at the survey and investigation stage of minimizing geological surprises, consequent engineering and contractual problems and delays. So my main point is, if you will do your detailed geotechnical investigation during the design stage, then you will avoid the geological. You will not get that much geological surprises what you will get before this detailed geotechnical investigation. The pilot tunnels in underground works. Okay, time is going on. New tectonic activities. The movement on faults disrupt the tunnels and its lining may cause offsetting of the tunnel itself. The sudden release of stresses may disrupt everything, including the support. In the belt intersect the numerous faults, the possibility of the movement taking place. So, if we are working in active fault zone, then we have to consider the stresses in that particular area. A good engineering design is a balanced design in which all the factors which interact, even those which cannot be quantified, are taken into account. The duty of the design engineer is not to compute accurately, but to judge soundly. The last conclusion. On the basis of the data collected, appropriate excavation and support system are to be designed and infrastructure is to be developed for taking care of any special geological occurrences that are anticipated. Number two, changes in the design are sometimes necessitated during the construction are the main cause of cost estimation and sometimes type overrun. The third one, proper planning and identification of all construction equipment and methodology of construction therefore are to be involved during the DPR stage. The last, only properly planned tunnel investigation at the DPR stage, identifying various inputs including motion, magnitude, complexity of construction, and handling the special occurrences can obviate the need of major modification and surprises during the construction. Thank you.
These presentations we are going to upload on the website, or we will be sending the electronic version by mail. I think everybody has given their email ID. Any question that can be discussed during the dinner time. Our next speaker is Mr. Akshay Mitra. We still want to emphasize that we are running out of time. Make it take 10 to 12 minutes. Only highlight the main points of the presentation. After the dinner, there is a small goodies or memento for all the young members that can be collected from the registration. So I request everybody to collect while going home from the reception desk. Thank you.
Respected dignitaries, my peers and friends. My name is Akshay Mitra Pawar and I am a tunnel engineer at GeoConsult India. My presentation today is about challenges faced during NATM tunneling in India. So the preamble is that you have decided on the project that you will work in some aspect with NATM tunneling and what possible problems you could face while executing that project. I have divided the presentation into basically 6 parts. The first, what challenges you might face while planning, while contracting, while you are preparing the contract, during design, during instrumentation and monitoring, during execution, and also what educational challenges we face in India when the field of tunneling is concerned. And then we will conclude the presentation. Let's quickly move on to planning. One of the bigger problems which we face in India when we do tunneling by NATM means is that sometimes in projects we adapt NATM in parts. That either you are doing your design by NATM or you are doing your contract by NATM or planning or whatever, but you are not adopting it in its totality. The thing with NATM is that when you adopt it in its totality, it works like a well-oiled machine, so that all aspects complement to each other, whether the design also you do as per the NATM, then your contract is also based on that. So you can get maximum benefit out of it. As I said, it is a start-to-end process from the idea to the construction, and everything has to be adopted to in totality to reap its maximum benefits. Let's just say in planning, if you have a chaotic project organization structures, which we see at times in some projects, where there are too many players in the project to take the decisions, and there is only one responsible party which has to okay everything. So there is too much burden on that party, and there is not much accountability and responsibility for other parties which are involved, and that inevitably leads to delays. And in not just NATM tunneling, in any tunneling projects, time is of very crucial aspect when it comes to a problem. If you are faced with a problem, you have to make quick decisions, otherwise the problem compounds and becomes a bigger problem. NATM loosely defines a structure where there is a client, which is the owner of the projects, then there is a designer, there is a site supervision or engineer, whatever you call it, and there is a contractor. These are the main parties, and there are then other parties also, but these are the main parties which have very clearly defined role. Like the contractor has to report to the engineer, and he has nothing to do with the client directly. So engineer has to handle the whole project, whether it is the design issues with the designer or with the contractor, and in the end, the engineer reports to the client. In that way, it is a bit more sorted project structure where your execution is better. Well, another aspect with respect to contracts is that when your project is not a unit rate contract, NATM is most suitable when it is a unit rate contract. It is not a lump sum contract. But when you have a lump sum contract, you have to complete your project in a pre-decided course. For example, let's say at the tender stage you have some geology based on whatever geological investigation you have done, and I'm not saying that you have done it less. Let's see, for this example, there have been large horizontal drilling as well as inclined drilling which you have done, and you have made a geological model at the tender stage by which you are asking your bidder to prepare a bid. But when you are actually excavating, it could be that you encounter something else where, because it's certainly not possible in every project, especially when we talk about Himalayas, to do that much extent of investigation where you know everything, which is not feasible also financially. But when you are, and this is actually expected most of the times, which happens most of the times. And if you don't give room to the contractor, then he has to finish the job in the pre-decided lump sum amount, but actual cost may vary in either directions. I mean, the geology could be better than what you predicted, or the geology could be worse than what you predicted. In either case, the price may vary. But if you have a lump sum contract, then certainly the contractor is not there to do charity. So he will try to somehow propose a claim or pose some delays to the project, and then everything becomes lengthy, and in tunneling, time is money. Well, as I said, NATM is more suited to unit rate contracts. Ground risk is always with the client in the NATM, because if you are bidding for if you are constructing a tunnel, then whatever the ground risks are with the client, and the contractor is responsible for the risk and safety of the project. Contractor has to ensure the rate of excavation as per the contract. And in NATM contracts, every contractor provides the rate of excavation in any specific geology or in any specific tunneling class. So even if the geology of that criteria extends or its extent become less, then also you can play with the rate, and your cost of the project is always variable based on whatever geology you encounter. Well, another problem which is faced quite regularly is that when in the contract, payment terms are as per the rock class classifications. When writing a contract, if you have written that the payment to the contractor will be as per the geology encountered, then this becomes a regular problem of site. Why? Because geology is always qualitative. Let's say there is a tunnel phase, and this one guy is client geologist, and there is another guy who is contractor's geologist. If he is trying to find out the geology of this phase based on QR RMR, which is certainly a qualitative system, you you calculate this with the fixed parameters which you have. Then let's say he comes that it is a class 2 rock. But the contractor geologist could have a different view of the geology, and he might play with the parameters and could acquire, reach a point where he says that it is a class 0. Well, if client geologist there, he wants to save money for the client, so he will try to keep it in as lower rock class possible, whereas the contractor geologist certainly will try to keep it in the upper class. And this makes a constant debate at site, and in the end, you cannot prove anybody wrong, because anybody wrong, I mean, in a class 2 or class 3 or class 3 or class 4, there is not much difference if somebody wants to prove that, and that's that constant debate at site cause to claims and delays, and that hampers your project. Whereas in NATM contract, payment terms are as per tunneling class. Some of you who are aware with this terminology of tunneling class is basically amount of support you put in a tunnel and with round length. These two are quantitative things. I mean, you certainly, if your geology is poor, you could do that. Either you increase the support, or you reduce the round length, or you do both. But in any case, the tunneling class calculated will be same for both the contractor's person and the client's person or the engineer's person. It is a quantitative value which cannot change when some construction is going on in a tunnel. So it's a quantitative value. So whatever you do, in the end, you have to reach to a point where you will reach a point where there is no debate, because it's a quantitative value. When it comes to design, this also causes a problem. When you have rock mass classification of the rock based on the Q or RMR or these type of systems, then it becomes difficult to relate the expected ground behavior with respect to the behavior type mentioned in the NATM. So let's say in the Q there are certain ranges which says it is good or bad or poor or very poor, and similar in RMR also there are different classes. And whereas in NATM there are 11 behavior types which you might encounter while tunneling. But if your contract says that you have to classify it as per Q or RMR, then in design you don't know that whether your extremely good falls under the stable, or it is under the shallow failure, or it is under the discontinuity based failure. One-to-one comparison, this could change, so it creates confusion at the site. Well, in NATM, as I said, you define behavior types, not the rock mass classes, based on whatever parameters you have arrived, and then you, based on the parameters of ground with respect to the tunnel, and then you arrive at a ground behavior. That what are your expectant ground behaviors. When it comes to instrumentation and monitoring, intermittent interpretation of evaluation of monitoring data is a big problem. That in tunneling, as such, the interpretation of your instrumentation data has to be continuous. If you do intermittent evaluation, then you are weakening a major pillar of NATM tunnel. I'll try to explain it with a small example. Let's say that this is a tunnel, and at the top you could see that this is, you are looking in the longitudinal direction from here. And the graph below shows you values. The blue settlement of left side wall with respect to ground. So this is basically percentage difference. So if you see that these both values are around 40, so when the let's say that now there is a fault coming, which you see in the plan that it is coming from the right side. When it is on the right side, your right side wall starts showing more settlements, and then your ratio of your right side wall to the ground suddenly increases. Now, if you are monitoring continuously, if your right side wall starts showing high settlements, you certainly know that there is some weak strata coming to the right side. Similarly, when you reach the fault, when you have not completely entered the filtering from the interpretation of the model, you can more or less guess that what you are going to expect, and then certainly you can be ready with that related problems that the optical targets get damaged near. In execution wise, there are some experiences which we have that the contractors excavating many rounds and then putting the support, which certainly doesn't go well with your stability. Then Elephant footing is sometimes chopped away while benching, which is also not good. Doing away with ceiling shortcut is certainly one of the things which is not good. Whenever there is a poor dewatering arrangement, your base area gets uneven surface and your vehicles start showing more breakdowns and there is more air which you have to evacuate. Then also if there is a temporary backfill, sometimes they fill it with a curry or temporary backfill, the whole invert comes out and you can have a serious collapse there. The last one, which is educational, the thing is that tunneling, NITM or others has not been penetrative in Indian education system as of yet. Very few institutes offer tunneling related courses and most of those courses are elementary and lacks industrial experience and such. Many of government clients do not have tunneling competency, not their fault. Therefore, quick decision making is absolute, which is percent with NITM tunneling. In Himalayan geology, and small errors could hamper the tunneling in a big way. Risk sharing is the way forward for any successful tunneling project. Thank you very much.
And our last speaker is Swati from Payasa. So 10 minutes.
Good evening, everyone. Topic for today is architectural design of tunnels and underground spaces, and I will be focusing more on the tunnel portion. The contents are basically methods of underground construction for metro stations, NITM tunnel application areas in metro stations, parameters for design and sizing of medium tunnels. Now, these parameters are primarily the inner profiling of the tunnel and not the envelope. Then we have the role of system wide and other disciplines in tunnel design. And last is the case study of a station in Mumbai, which is Kalpa Devi. So it is an upcoming station and it is still under construction. So the types of underground construction methods and specifically for tunneling are cut and cover, CBIP and NITM, which all of us are aware of. And out of that, I'll be focusing on the NITM part. Now, in the NITM method, the application of NITM tunnels are, we have a main tunnel, which is the platform tunnel. Then we have the access ways, the access passageways, which are the connecting tunnels to the main platform tunnel. And then we have the central station tunnel. Now, the main platform tunnel is what you see is where you have the main platform. And from the image, which is actually a proposal for underground, it's a very wide area with considerable height and it looks beautiful. But what we usually get is a section which is on the side where you see that we have all these things. So we have all these things coming over the wall ceiling. So it's not kind of this profile, which it might be, but we do have some height reduction due to things coming over this. And we do have some things here, and we have a big obstruction which is PSD, which comes right here. So next is the access tunnel or the passageways. So we have two kinds. We have divided into two kinds because we need to have some connections. Now this kind of a passageway is the one where we want to connect it with the undercroft also of the station. We want to take some services below. And we want to transfer those from the tunnel portion from the track side to the undercroft of the station. This kind of a section is where we do not require those connections. So we would want to have a smaller profile there. Now this is the central tunnel where this portion is also a tunnel in the center, which is having a main vertical transportation element for the station. So it is housing basically the stairs and escalators, which will be leading to the concourse of stations. And so it is a combination of all the three kinds, which is the platform tunnel and the access passageway and the central tunnel. Now this, the parameters for design. So this is a typical section which we have. Now the difficulty with this kind of a section, when we start with this, we get this outline, which is fixed, the structural outline of the tunnel. And then we try to fit in the other things which we require in the tunnel. So we get this ventilation ducts, which is the overdrain exhaust and the other platform exhaust. And both of them have a particular sizing. And so we get to arrange that. Then we have the elements which are for the platform, which is the station, supply and exhaust. And we also have the false ceiling and the other profiles. We have the lighting and we have the signages and everything will come. Then we have, then what we start doing is we try to modify those things. We try to enlarge this, we get this here, we bring this ceiling down, we try to increase this. But as we see, this is not working. The profile that is given to us is not working and nothing fits in. We do not get the drainage here, we do not get the full fits. So and which is important for transferring the cables. So this kind of a section, though it looks very nice, but it is not working in terms of the functionality. So then we have another approach. No, this approach we can also adopt if we are ready to have some innovations and we are ready to have we optimize the other solutions and we have time to have research on creating new solutions which are not the standard traditional ones, and it can be designed. And we come to another approach where we have this fixed criteria, which is the platform edge. The track center line and the platform edge is a fixed criteria as per the schedule of dimensions. Also, the platform width is another fixed criteria because we have done the sizing calculation for this element. Then we have the height which we require because we do not want to feel claustrophobic in a station. We want a particular false ceiling height. Then this dimension, which is the rail level to the bottom of the OTE, is also a fixed dimension. And it is provided in the ODS, the outline design criteria, and also in the schedule of dimensions. So all these are fixed. Plus, we know that we will be having the cables which we have to transfer, and we will require certain drainage which we will be transferring from one side of the track to the other side. And then we know we do have an area requirement which is already provided in the design criteria. So we have these elements. So we get certain extents for designing the envelope. Okay, that is the duct for the station supply. So we get an outline of how we would want the tunnel profile to be. Then we can optimize this definitely, and we can have a solution. As we see that this was not working, the cable tray arrangement. So we could have a solution of having HT pipes for transferring the cables instead of having a normal pulpit, which is of a bigger size. So we can think of solutions like that, but after arriving to a profile which is more suited to all the requirements. And then we can optimize it further by checking the structural requirements. Now the role of system-wide and other disciplines. So we have, other than architects and structural engineers and the services, we have other system-wide input also, which have their services running in the tunnels. So we have the SLT, signaling and telecom. Then we have the power cable trays, LT cables. Then we have SCADA, which is mechanical and electrical. Then we have electrical cables again. These are for the lighting as well as for the signages. So we have those things running there. And we have the TVS tunnel sensors. Then we have the general electrical and plumbing, which is called the station. So we have all these services in tunnel design, which we have to consider while we are designing the interiors of the tunnel. And basically, it is more important for deciding the size of the height of the tunnel. Now we go to a case study of Kalpa Devi station. If you've been to Mumbai, you will be aware that this is a very crowded area, and particularly Kalpa Devi and Gurgaon are very crowded, and we have very less space for construction at site there. So we have this station which is partly cut and cover, and it has all the three kinds of NADM tunnels. And the size of this, if you see, is just 10 meters by 49 meters, and the overall box, cut and cover box that we have is 20 meters by 50 meters. So we have two cut and cover boxes of that size. Then we have a connecting tunnel, which is below. So we have our entry elements, vertical transportation elements going from on both sides, two accesses. And this is what we see if we go down. We have two separate boxes, which is the mezzanine level, where we have all the services and the AHUs and all those things. We are housed in this area. Then we have a concourse, which is this portion of which is a cut and cover. This is a deck which extends to the central NADM, station NADM, but we do not have a connection between the two. There is no opening. Then if you go to the platform, you can clearly see that this is my platform tunnel. These are my cross passages. And this is my central station tunnel and my connection with the cut and cover box. So if you go to the section, this is the typical section through the cut and cover area. Then we have a connection with the central NADM, and we have a double height space in between. That's a huge space in between. But we do have a deck in the central tunnel. As you can see, we have very less space in the underground for the services. So later, we had modified this section. So this is the kind of section that we have with the cut and cover box, the intermediate levels, and the central connection. So this tunnel basically is a 10-meter high tunnel, and it was very high. And we had a lot of difficulty. I mean, our structure team had a lot of difficulty in planning for this. So we had to modify it later, and we had to bring it down to the size of these. So we had to reduce one of the decking level. And this is a BIM model which we prepared for the same. So this shows the connecting panels. This is the upper level. That is the connection to the ground. That is the code section.
Thank you very much. Now I invite Dr. General Suresh Sharma to grace the dais. It will not take much time, only one small thing. We have quite interesting presentation, and we are really very sorry. We had one presentation because we were overshooting the time and we could not accommodate one presentation by a person, Mr. Ahmed Shah from right. So maybe the next time we can plan in a very different way with the more time. Sir, because I request you to do the honor by presenting a small memento to the speaker of the session. May I now invite Dr. Florin Crane. Mr. Sandeep Singh Nirmal. Mr. Ajaz. Akshay Mitra. Swati,
Yes, please.
so thank you very much for doing the honor. So, would you like to say something? Or
So we just take a minute. But ladies and gentlemen, I think to begin with, it was a good effort. You all have put in sincere efforts. Some people have come very well prepared. I'm sure there must be a lot of questions to be asked. So we'll reserve our questions. You can ask each other to the speakers when you go down for the dinner. We're not going to delay you because you have long places, long distances to cover. But once again, I would just repeat, the sky is the limit. In this case, not the sky, I would say you're not going skywards, you're going downwards. So you can develop yourself shape yourself into a very, very good learning professional. Whether you are a consultant, you become a designer, you become a teacher, you become a researcher, or you become a contractor, or you become a client, or whatever you thought of. But only I would say recommendation to you is stay connected. This world is a really, really very, very interconnected world. And let me tell you, whatever experience I have of the learning world, it's a very, very close community. And Dr. Florian would bear me out. It's a very closely knit community. Interact and connect with people more and more. You will learn more, you will experience more, and you will get into this network mode, which will offer and which will open up more and more opportunities for you. With that, let's conclude. And thank you once again. Thank you to the organizers. Thank you to the leaders.
the last activity is group photograph. Now you have to adjust yourself in this film. And photographer has to do some job.
He will tell you where is the architect now. Now where is the space? Let's see where she is now.